Today we are going to introduce our workforce framework of rule-based conversational recommender system. Our work is motivated to build CRS bots with low cost and interpret-able approach. Conversational recommender system has attracted lots of attention recently because it captures users' real-time feedback through interaction and then make better recommendation. Academic works on CRS are mainly based on deep learning models, which require plenty of annotated data for each domain. However, in industrial products, the time and financial cost to annotate all domains is unbearable. Especially in e-commerce field, there are usually a large number of entity categories. We are motivated to build a framework that can support developers in constructing low-cost, cold-start CRS bots. Only entity attribute data and straightforward configuration are needed. Compared with major practices to build CRS bot, our rule-based framework does not require annotated conversations and construct the simplified KG automatically from structured data. Here is the initial view of the Force Live demo. First, developers need to select or create a new knowledge graph by uploading a TSV file. For the first conversation, we are going to build an English chatbot about movie recommendations. Now we proceed to the second step. Since the movie recommendation is an entertaining scenario, it is suitable to use the casual mode. Developers can further customize the style of the bot by adjusting the ratio of 3 bot intents. For professional developers, 2 advanced settings are available. The query understanding and response generation modules are also configurable for different scenarios. Now, this is the main page of the bot. The left part is a chat window. When the user finishes the sentence and hits enter, our system would parse the user utterance into the inferred user intent and the mentioned slots that appear in the KG. As the conversation proceeds, the panel on the right shows the current status of the bot, including the bot intent and an interactive KG visualization. The coloring index can be found in the node info. In this turn, the bot makes a recommendation. As we accept the recommendation, the conversation ends. Here we apply our system to another domain music recommendation. We also use casual mode for this domain. The query understanding and response generation configuration is changed to fit this domain. The bot is asking for our preference for singers. As we provide the name of 2 singers, the bot recommends a song from one of them. Then we ask for a song from the other singer. The bot recommends accordingly. The node of the previous song turns red because we did not accept the recommendation. Now we accept it and the conversation ends. Now let us reset the model and configure it in another scenario. Disease pre-diagnosis in Chinese. Since the recommendation in this scenario should be more careful and precise, we choose the cautious mode. Similarly, the user can adjust the values for advanced settings and configurations. We disabled the customization for basic settings to ensure the professionalism of the mode. Since the system would not recommend until the threshold is met in the cautious mode, the bot continues to query. Here we reject the recommendation and provide additional information. The N means the user has denied the slot. After providing additional information, the bot successfully recommends the most likely disease according to the given KG and provides related information. We now accept the recommendation and end the conversation. Here is the system overview. We build the system with MVC architecture pattern. The modules are decoupled by predefined interfaces, thus each module can iterate independently or be replaced with machine learning models later. We will briefly introduce the core modules one by one. The knowledge graph reasoning layer is responsible for connecting the system to a simplified knowledge graph, which is constructed by uploading a data file as in previous demo. Following the cited work, we define 3 types of nodes in KG: entities, attributes and generic classes. Each entity is related to a set of attributes, while each attribute is connected to its corresponding generic class by an edge. For example, the movie Catch Me If You Can is an entity that has many attributes, such as crime and Tom Hanks. Crime belongs to the genre generic class, and Tom Hanks belongs to the actor or actress generic class. This module provides various reasoning algorithms on KG, and serves entity ranking and dialogue act generation module. Now it comes to the execution flow of the system. The query understanding module receives user utterances and parses them into a semantic frame, which is a structured representation of user intent and mention slots. We use simple keyword matching according to developer configuration as shown in previous demo. AAAI Corasic automaton is used for matching efficiency. The entity ranking module ranks all candidate entities by matching score according to conversational context. Entity neighborhood and mentioned attributes are both considered in the ranking. The bot intent prediction module decides which action the bot should take at the current turn. We empirically summarize and implement the condition decision rules for interpretability. For example, if the last bot intent is query, and the current user intent is provides lot, then bot will determine whether to recommend or continue query based on the configured matching threshold. The preference for chat, query and recommend can also be adjusted by configuration, which is used to form the style of the bot by probability sampling in ambiguous situations. Dialogue act generation module infers on the knowledge graph to generate a structured representation of the next action the system should take, called the dialogue act. If the bot intent is query, the bot selects core nodes from the generic classes and selects the neighbors from the related attributes which have not been mentioned yet. If a bot intent is recommend, the bot selects the entity with the highest matching score as the core node. The neighbors should be the related attributes of the entity. If the bot intent is chat, the core node should be the most recently mentioned node. The response generation module converts the dialogue act into the bot response in natural language form. Concretely, the bot picks a configured response template to current bot intent first, and instantiate it by information from the dialogue act. We conduct experiments into different domains with different languages to verify the effectiveness of force. Both datasets are sampled or reprocessed based on open dataset. Considering the cold start situation, our results are satisfactory compared with random baseline. With the configuration in previous demo, the intent accuracy in both domains gets nearly 67%. Actually, a different intent from the human does not indicate a poor choice. It's more about the style of the bot. We paste the intent accuracy and entity recall of the cited C or Walker on full redial as a reference. To sum up, Force is proposed to construct cold start CRS bots with good interpretability. We conduct experiments to verify its effectiveness and usability. It is worth mentioning that CRS bots by Force can also be regarded as a conversation collection tool in early stage. Developers can annotate the top domains and fine-tune each module independently with deep learning models in future iterations.